Hey runners, just another running coach here, back after a week off from videos. I hope everybody's summer is going great. You can see today I'm rocking my Achilles Kids Guide shirt. Last weekend I had the thrill and honor of being in the Achilles Hope and Possibility 4-mile race as a guide. I was guiding one of the kids in the kids program, and if you're not familiar with Achilles International, they're one of the great organizations out there. They do amazing work with athletes of all abilities. And the race last weekend was just one of the greatest, most positive, life-affirming events that I've seen in a really long time. It was the first mass start race here in New York City in a year and a half since COVID. And besides that, I mean, the Achilles races are always the greatest celebratory events. It's really impressive seeing the extraordinary achievements of these athletes who overcome so much adversity. But beside that, it's just a super fun event all around. So if you've never run with Achilles before, I really encourage you to look out there for your local chapter, get in touch, and have fun, make some new running buddies, and enjoy. It's a great time always. So today's video, I want to talk about the most important piece of equipment in a runner's arsenal. And no, this is not another video about footwear. Some might think it's a fancy GPS watch or one of those amazing leg massagers you see in the store windows, but believe it or not, there's an even better, even more complex piece of technology that every runner needs, and it's worth way more than all those things combined. If the video title hasn't already given it away and you're still wondering what this incredible piece of running equipment is, all you have to do is look in the mirror, because you've had it all along. Nowadays, with the fitness and running industry showering us with advertisements of all these new, innovative gizmos and gadgets that promise to take our training to the next level, it's easy to overlook the amazing equipment each of us came into this world with. And it makes sense because our bodies are complicated. Trying to understand how exactly chemical synthesis and nerve impulse propagation works sounds pretty darn confusing. So it's no wonder why we have a tendency to look outward rather than inward. However, in this video, I'm going to try to change that just a little bit by giving you a brief rundown of how our bodies, down to a cellular level, make the magic of running possible. I will warn you, this subject's a little more dry than others, but if you stick around, I promise you'll be just as amazed as I am at how impressive and strong our bodies are, no matter how we may feel about them sometimes. Plus, you'll have a better understanding of why we train the way we train when we follow a plan. By the way, if you ever want to skim through these videos to find specific information or skip parts you already know a lot about, keep an eye on the upper corners of the screen as you scroll through the video to find the topic and subtopic you're interested in. I figured it might be helpful for anyone who's looking for very specific information or ever needs to revisit one of these videos without rewatching the whole thing, as much as I'm sure you love watching me talk and hearing my voice. So without further ado, welcome to my very simplified version of Running Biology 101. Boiled down to its simplest form, running, like many other activities, is an aerobic exercise, which means it's a form of exercise that relies upon oxygen. You might be thinking, well, doesn't everything require oxygen? And you'd be absolutely correct. Right now, even if you're sitting, standing, or listening to this while you're washing the dishes, no offense taken, I do it too, your body is using the oxygen that you breathe to give you energy. Basically, this applies to pretty much any exercise or activity you can sustain for a long period of time. On the other hand, when a form of exercise is so intense that the body can't rely on oxygen alone, such as push-ups or all-out sprinting or running for the bus, that's called anaerobic exercise because oxygen by itself is not enough to sustain that intensity, and the body has to turn to other measures to produce enough energy for your muscles to keep contracting quickly and powerfully enough. Since it's not going to be very useful for us as distance runners, we're not going to focus too much on anaerobic exercise right now, but we'll come back to it in a bit when I talk about different types of muscle fibers. So keeping in mind that I'm not a biologist, here's a super simplified breakdown of how the aerobic process works in the context of running. First, we breathe in oxygen, which gets absorbed into our bloodstream. And then, the strongest running muscle of all, the heart, pumps that oxygenated blood all throughout the body, but especially to the muscles that are working harder than usual, aka your legs. Now, if we zoom all the way into individual cells, our teeny tiny mitochondria, powerhouse of the cell, they take that oxygen and start producing energy in the form of a molecule called ATP, which is shorthand for adenosine triphosphate. Not Association of Tennis Professionals. Sorry, fellow tennis fans. That ATP is the magic dust that allows our muscles to contract, and it drives all kinds of important processes such as nerve impulse propagation, chemical synthesis, and a whole bunch of other stuff I don't even know how to pronounce. But basically, the more ATP you can produce, the longer you can run, the faster you can run, and the stronger you'll feel. Speaking of which, this is biology after all, so I want to dissect and redefine a common piece of running terminology related to this point, running economy. The scientific definition tends to go something like oxygen consumption relative to a runner's weight and speed. But A, that's kind of boring, and B, I don't really like how it places so much emphasis on weight and speed. From a purely mathematical standpoint, it makes sense, but I don't want anyone out there to hear that and think losing weight is always the answer. And with speed, we also don't really want the concept of running economy to feel like a competition either. Instead, I prefer to think of it in two ways. One, how quickly you can create energy, and two, how efficiently you can use it. Another fun way to think about it is to be super literal and think of running as an actual economy, with ATP being its currency. You want to make a lot of ATP, and you also want to be able to save it and spend it responsibly. Otherwise, you might just crash. It's kind of a silly analogy, but unlike real capitalism, it's not a zero-sum game. You can have as much ATP as you want, and it won't take away anything from anybody else. Ultimately, I find these to be more productive ways of thinking about running economy because we can focus more on training the physiological systems that are more directly responsible for creating and using that energy. And that's something equally important for all runners, regardless of weight and speed. So you might be asking yourself, how does one master the art of ATP efficiency? And here's the best part. Your body knows exactly how to do it. You just need to give it a little encouragement. As humans, we are really good at adapting. Here's an easy example. If you've ever traveled to some place at a much higher altitude than you're used to, you may find it much harder to run or really do anything that tests your breathing. But the longer you stay there, you'll find that it gradually becomes easier to breathe, and that's because your body's adapting to the change in the amount of oxygen at that altitude. If you work a very physical job, same idea. You might feel really sore after your first day, but over time, you won't feel as sore as you did at the beginning. With aerobic exercise like running, the more we stress those systems, the more our bodies will respond by making those systems more efficient. This is why it's really important to train with consistency, because even though your body's listening to stress, it won't do a great job of adapting to it unless you make it clear to your body that you're going to be repeating that stress often. It is really easy to take it for granted, especially because we can't necessarily feel these things happening all the time. But with consistent training, especially at an easy conversational pace, it's actually mind-blowing how many things change and improve on the inside. Our muscle cells increase in number and size, we build more mitochondria, oxidative enzyme activity increases, which is just a fancy way of saying oxygen can be delivered and processed faster. Your capillary density increases, which helps your blood vessels retain more oxygen per breath. And your muscles' ability to manage waste products like carbon dioxide, hydrogen ions, and lactic acid all improve. And those are just the aerobic improvements. That's not even taking into account bone and soft tissue resilience, muscle fiber recruitment, and a ton of other things that improve with training. The only caveat that you have to keep in mind, as exciting as it is to just get out there and start building more mitochondria, is there is such a thing as overtraining. And especially with running, it's really important to take it slow, especially if you're increasing your weekly mileage or the intensity that you're running that mileage. If you exhaust yourself too much, your body won't be able to recover quickly enough to make those adaptations, and it'll just be a bummer. If you can carefully balance that, perhaps with the help of a coach, the sky's really the limit. And I would argue that most people significantly underestimate how much they can improve just by focusing on achieving that balance in their training. The last thing I want to talk about is where some limitations do start to come into play. And I don't want this to be discouraging in any way, but it does help us understand why we can't all be elite runners, which, by the way, doesn't really matter. It is true that with the right resources and dedication, you can make amazing strides. But one advantage the very fastest runners have over the rest of us that we can't control has to do with the type and distribution of our muscle fibers. All of us actually have 3 different types of muscle fibers, and those 3 types are slow twitch type 1, fast twitch type 2A, and fast twitch type 2B. In case that doesn't mean anything to you at all, don't worry. For the sake of simplicity, feel free to think of it like this. Slow twitch type 1 are your aerobic fibers. These are by far the most useful for 99% of long distance running, because even though they're not particularly powerful and they're slow to contract, they are jam-packed with mitochondria and capillaries, so they take much longer to get fatigued. On the other end, we have fast twitch type 2B, and those are your really big, thick anaerobic fibers that are especially helpful for short, powerful contractions like sprinting. But they're really low in mitochondria, so they tire out pretty fast. And finally, there's fast twitch type 2A, which have the unique property of being convertible. So with the right training stimulus, you can actually develop these fibers to behave like either of the other 2 types. Now, each and every one of us has our own unique ratio of these muscle fiber types based on our genetics. And most of the population has a close to equal ratio of aerobic and anaerobic fibers. The exception, of course, being the elites, who just have a crap ton of slow twitch fibers. But here's the beauty of it. We also all have a certain number of those convertible fibers, which we can think of as a huge source of untapped potential. And unless you go through extensive testing in a laboratory, there's really no way to know what your fiber type ratio is. So I encourage you to stay optimistic and train like those fibers are in your favor. No matter how many convertible fibers we have, to get the most out of those fibers, we want to do a lot of easy running, particularly those long runs over 90 minutes, because after your slow twitch fibers fatigue, that recruitment of those convertibles begins to take place. Just make sure the rest of your body is ready to take on those kinds of runs. So if you made it this far, congratulations, you've graduated from Running Biology 101. I hope this video has been helpful, and I especially hope it's given you a newfound appreciation for how strong and well equipped our bodies are for running, no matter what shape or size they come in. So until next time, go make our evolutionary ancestors proud, and happy running.